Greetings and welcome to Introduction to Music Production Week 1 for Coursera.org. This is the first of the student assignments wherein we have to create our own lessons. My name is Nathan Moker. I'm from Avondale, Auckland, New Zealand, which is a real country to the southeast of Australia. Few in people, but beautiful in land. So today, as you can see on the screen, I'm talking about the very basics of audio to make sure that that is certain and we understand that before we proceed to more important and harder to understand things, especially focusing today on propagation, amplitude, and frequency. So, before I speak of that though, it first must be understood that sound is a longitudinal wave rather than a transverse wave. We can see here in this illustration that this is a wave, like light, sound, or water are probably the three most common examples. And in this wave, this is a sound recording to represent it, but it does not fully show it because this shows a transverse wave wherein the propagation is perpendicular to the oscillation of the sound. In a longitudinal wave, the propagation is parallel to the oscillation. So, to explain that, need to explain what is propagation. So propagation is quite simply the direction in which the sound is traveling. So looking back at that illustration, the propagation here is this, the way the sound proceeds. And when we hear sounds, we use the timing that they come to our different ears to perceive which direction the sound is coming from, which is an amazing part of our ears, which are truly wonderful devices, and in fact quite better than any microphones which we have been able to design. But anyway, moving forward, so propagation is direction, and amplitude is the height of the wave, which we perceive as loudness. So in this illustration, the amplitude of the sound is this bar here, the height from the center of the wave. So, and amplitude is identical to, it is not identical to, but it is very much related to concepts of quietness and loudness. So when sounds have a small amplitude, they will be perceived as quiet, while when they have a large and high amplitude, they will be perceived as loud because of the waves being wider than they are previously. So amplitude is not loudness, but we perceive it as loudness when our ears process it. And the final, just as important feature of sound is frequency. And frequency equals the speed of a sound divided by the wavelength. Now, wavelength is the length from the two crests here between the two waves. The crest is the top of the wave and the trough is the bottom of the wave. So the wavelength is equal to the distance between the two crests. So frequency equals just the speed that the sound travels divided by the wavelength, and that results in units that are 1 per second, and they are also known as hertz after a great scientist who who helped discover these various properties of sound. So, to summarize, there are three most essential properties of sound: propagation, which can be simplified by simply saying direction; amplitude, which is the height and which our ears process into loudness; and finally, frequency, which is the speed. And changes in frequency are what the longitudinal property of waves, then, is that the propagation, the direction that they travel, is parallel to the oscillation and the vibration. It's very hard to show here, but it is similar to the children's toy, the Slinky, in that it goes back and forth and vibrates at the same time. It's a difficult concept to grasp, but it is essential to be able to process and record sound further in any endeavor, especially in the creation of music. Thank you for taking time to listen to this recording. I hope you enjoy it and it helps you a little bit, and thanks once again for taking time to listen.